Hello viewers, welcome to the class. I'm back in this series of Get Winner for EC solutions. This time starting the new subject networks. After completing general aptitude and Indian mathematics, 4 questions came from basically from networks. All were numerical answer type by NAT based, 2 1 mark and 2 2 marks. So we'll start the very first question from the subject networks that came in GATE 2024 EC. Question number 31, 1 mark in any type. On the official master questions of GATE 2024 EC is as follows. 1 mark in any type. Question number 31. It is given in the given circuit the current Ix milliampere circuit is given as something like this. 1 milliampere resistor is there, 1 kilo ohm. This is I0. Thousand I0. 1 kilo ohm. Milliampere. One kilo Ix. Let us know the solution to this question. Pretty simple question actually. Can be solved by applying basic circuit analysis laws. So let's start by applying KCL at this point. Kirchhoff's current law. What does it give? 5 milliampere. All currents in milliamperes, let's skip. Okay. 5 equal to I0 plus 2 plus Ix. So I0 plus Ix is equal to 3. C equation 1, let's say. Okay. Let's apply KVL in this loop. As shown. What do you get? I0 is in milliampere, all currents in milliampere. So milli into kilo gives nothing, cancel out. So this current is flowing in this direction, right? So this is the rise. So I0 into 1 is also rise. So thousand I0 actually 1000 here it is same as 1 kilo. It is 1 K I0. So as we are not writing K because I0 milliampere, we will write 1 here. So okay, this will be I0, right? And here it will be what? This rise, but this is not rise. This is a drop. So it will be minus Ix into 1K. Again 1K we are not writing K here. So it will be 0. So from here what do we get? Ix equal to 2I0. Using equation 1 and 2. From equations 1 and 2, what do we get? 2 just putting 2I0 in place of Ix. So 2I0 plus I0 equal to 3. So I0 equal to 3I is equal to 3, I0 equal to 1 milliampere. Now substituting this I is equal to 1 milliampere in equation 2, we will get Ix equal to 2I0, that is 2 into 1 milliampere, that is 2 milliampere. So the question is asked Ix in milliampere. What we will get, Ix is 2 milliampere. So Ix in milliampere is what? Ix in milliampere is 2. Simply 2. So as the numerical answer type question, you have to fill in the blanks. The correct answer, which is 2 in this case. Very basic, very analysis, circuit analysis. By first applying KCL at this point, then applying KVL in this loop to obtain two equations in I0 and Ix, and solving them to obtain I0 is 1 milliampere and Ix is 2 milliampere, which is asked basically. Ix in milliampere is 2. So I have shown all the detailed steps for this question in order to solve this. If you still have any doubts or queries in this pretty simple solution, please feel free to ask in comments. And that's all my question to this solution to this simple question. Moving on to the next question. This is a gate for EC solutions from circuit networks. Question number 32, again one mark, NAT type, numerical answer type, from transients basically, time constant. Question number 32, the official master version of gate for EC from circuit networks is follows. 1 mark, numerical answer type. It is given in the question. In the circuit given below, the switch was kept open for a sufficiently long time. And is closed at time t equal to 0. The time constant in seconds of the circuit for t greater than 0 is given as dash. Circuit is given as like this: 5 ampere, 2 ohms, 3 Henry, 4 ohms. This will switch closed at t equal to 0. 4 ohms. Basically, let's move to solution to this question. Basically, this time constant is asked for t greater than 0. For this kind of circuit where there is one energy storing element, say L, we need to find the, and others are resistances, energy dissipating elements, and one energy storing element L. Others are resistances. So across the energy storing element L can be C also, capacitor also in some of the cases. What we need to do, we need to find the equivalent resistance of the circuit across L. For finding the equivalent resistance, what do? We deactivate the independent sources. That is, we open the current sources and short circuit the voltage sources. Here only current source is there. So basically we will open it, and after at t greater than 0 means this will be in closed condition. So basically this will be what? Right. This is the equivalent circuit. We need to find R equivalent across this inductor. Equivalent circuit. Equivalent circuit for t greater than 0. So basically, you have to find R equivalent across the 3 ohm inductor. R equivalent will be what? Simply 2 ohm in series with 4 and 4 in parallel. So 2 plus 4 parallel 4 ohms. 2 plus 4 into 4 upon 4 plus 4. So this is 16 by 8. So 2. So 2 plus 2 ohm. So that will make it 4 ohms. Right? So the R equivalent across the inductor is 4 ohms. Now time constant for first order R L circuits is given by tau equal to L by R equivalent. L is here what? 3 Henry. R equivalent as we determined here is 4 ohms. So 3 by 4 is 0.75. And as these are SI units, the time constant will come in seconds directly. So the correct answer, which is the time constant of the circuit for t greater than 0, in this case is 0.75 seconds. As we summarize the very basic approach we have followed for the simple first order circuit as the one given. Across the energy storing element, which is inductor in this case, we have found the equivalent resistance by deactivating the independent source 5 ampere current source by opening it. We have found the equivalent resistance by as 2 and 4 and 4 in parallel in series with 2 ohms. So that gives 4 ohms as the equivalent resistance. And then the time constant for t greater than 0 after closing the switch will be simply the energy storing element is L, in this case L by R equivalent. Tau equal to L by R equivalent. L is 3 Henry and R equivalent will be found as 4 ohms. So that will be 3 Henry will be found, that is 0.75 seconds. And the question is asked the time constant of the circuit for t greater than 0 in seconds. So the answer is basically very easily obtained as 0.75. One of the very basic approach of finding the time constant for a first order RL network. तो हम लोगों ने बहुत आसानी से इसका आंसर निकाल लिया 0.75 सेकेंड्स और सॉल्यूशन मैंने बहुत ही डिटेल में डिस्कस किया है. If you have doubts or queries, please feel free to ask in the comments. And that's all for the solution of this simple question. Moving on to the next question in this series of gate driven for EC solutions for subject networks. Question number 60 in the official master question paper of gate driven for EC for subject networks. 2 marks, again numerical answer by any type. Fill in the blanks. From 2 port networks, question number 60 is as follows. 2 marks, numerical answer again. It is given the question for the 2 port network shown below. The value of the common parameter. Y21 parameter. Of course, in Siemens, is within the blanks of the right value circuit 2-port network. Something given us. This is 2 ohm resistor, 4 ohm resistor. Dependent voltage source is there. V1. This is I2 basically. I1. This is V2. Standard convention, following the standard convention of 2-port networks. current entering. This is V1. Okay. Let's solve. Very basic definition of. Let's move on to solution. Definition. Very basic definition of y parameters. Definition equation basically. I1 equal to y11 v1 plus y12 v2, and I2 equal to y21 v1 plus y22 v2. We are the defining definition equations of y parameters. Now we will apply circuit analysis to this. We are given two-port network. Okay. Applying circuit analysis here. 2 and I1 is flowing this 2 and ohms resistor. I2 is flowing here. So 4 ohm resistor current flowing will be what? Is equal to I1 plus I2. Okay. Let's apply KVL in this left loop. KVL. Left loop. This is V1. Rise. Drop is minus 2 I1. Minus 4 I1 plus I2. And here is what? Plus 8 V1, because this is the increase. Rise, right? Okay. Right. One thing you can write it this. Another way is representing this. This voltage is same as this voltage, so we can write this voltage here. So again, what we can write V1 minus 2 I1. Replacing this with V2. So minus V2. What is it? So from here we get what? I1 2 I1 equal to V1 minus V2. V1 minus V2. 2 I1 taken from that side. So from here we get what? I1 equal to V1 by 2 minus V2 by 2. Right? Okay. Now, what you can write it? You can have a KVL in right loop. KVL in right loop is what? V2 equal to 4 into I1 plus I2. I1 plus I2 will be rise, so minus it. Because we have taken the drop as positive on the edges, so rise will be minus, so minus 8 will be. Okay. Now what we can do, substitute this equation, let's say this is equation 1 here. This equation. So what we if we substitute equation 1, we will get V2 equal to 4 times I1 will get us V1 by 2 minus V2 by 2, and 4 I1 plus 4 I2. So we are getting 4 I2 separately. Okay. And minus 8 V1 as it is. Okay. Let's simplify it further. V2 equal to is 4 into V1 by 2 minus 2 into V2 by 2, that is 2 into V1 minus 2 into V2 plus 4I2 minus 8 V1. Now collecting all the terms of V1 and V2 on one side and I2 on the other side, what do we get? 2v1 minus 8v1, so this will be minus 6v1. Minus 6v1 taken to that side, so it will be 6v1. Let's keep 4i2 here. So 4i2 equal to 6v1 taken to that side, 6v1, and here what will be v2 plus 2v2, 3v2, that's it. Right? 4i2 equal to 8v1 minus 2v1, that is 6v1, and plus 2v2 plus v2, that is 3v2. So 4i2 equal to 6v1 plus 3v2. Okay. So i2 will be what? Dividing both sides by 4, so it will be 3 by 2 v1 plus 3 by 4 v2. Equation 2. Now we can compare directly these equations 1 and 2 with the standard y parameter equations. Okay. As they are in the form I1 equal to v1 something v1 plus something v2. Like that. So comparing the parameter, the both equations, the standard equations of y parameters, we get what? So it y11 will be what? Coefficient of v1 in the equation I1, which is what? Half or 0.5 seconds. Similarly, y12, coefficient of v2 in the equation of I1, which is minus half, it is minus 0.5 seconds. Similarly, y21, the coefficient of v1 in the equation of I2, which is 3 by 2 or 1.5, and y22, the coefficient of v2 in the equation of I2, which is 3 by 4 or 0.73. So y parameters you have obtained is 0.5, minus 0.5, 1.5 and 0.75. But question में बस एक ही पूछा है, question में y21 parameter is asked, and we have obtained it easily as 1.5 seconds. y21 as asked. बहुत ही आसानी से हम लोग इस क्वेश्चन को सॉल्व कर लिए हैं. इसका आंसर मिल गया हम लोग को 1.5. I've shown the detailed steps. First applying basic circuit analysis, KVL in left loop to obtain I1 in terms of v1 minus 2i1 minus v2 equal to 0, so I1 in terms of v1 and v2. Next writing KVL in the right loop. Okay, this. So v2 we obtain relation between v2, I1 and I2 and v1 also. Now substituting I1 in terms of v1 and v2 from equation 1, we get I2 in terms of v1 and v2. And comparing, because last में compare करते हैं दोनों equation को I1 I2 को जो मिला है in terms of v1 and v2, standard equations, उससे हम लोग मिल जाता है all the y parameters y11, y12, y21, y22. बस y21 ही पूछा क्वेश्चन में, जो कि यहाँ पे वैल्यू मिल गया है 1.5 seconds. So I have shown all the detailed steps and explained it step by step also for clarification. If you still have doubts or queries for this simple solution, please feel free to ask in the comments. I will be glad to answer. And that's all the solution to this question from Google Networks that came in day 2024 BC. Maximum power is to be transferred to the load RL. To the load RL. Network is given as something like this. ohms, this is 3 ohms, this is Vx, this is also Vx. Okay, this is the circuit. Networking. Okay. And it is asked the value of RL is dash in ohms. Of course. Let's move on to the solution for this question. Solution का आगे बढ़ते हैं. बहुत ही आसान क्वेश्चन है. Maximum power transfer theorem से. So plain and simple DC network, as you can see. So for maximum power transfer, according to maximum power transfer theorem, power transfer to load RL should be equal to the Thevenin's equivalent resistance. So that was this RTH. Maximum power transfer to load RL should be equal to RTH by maximum power transfer theorem in DC networks. So basically what we need to do is we need to find the Thevenin's equivalent resistance across this load resistance RL. Thevenin's equivalent resistance is nothing but the equivalent resistance after deactivating the equivalent resistance found after deactivating independent sources. Deactivating all independent sources. Here in this case, only one independent source is there. It's 50 volt source. Voltage source is always short circuit. Shorting 50 volt. So basically the equivalent circuit will look like this. Vx 2 ohms, another 2 ohms. This is also Vx. Okay. And finding the equivalent resistance across this load resistor RL. इसके लिए हम लोग क्या करेंगे? वोल्टेज सोर्स लगाएंगे जिसका मैग्नीट्यूड कोई कुछ भी मान सकते हैं. वैसे मैं मान रहा हूँ उसको V and it generates a current I. It makes it flow into the circuit. ठीक है? This 3 ohms, right? तो करंट ये कितना करंट होगा? This current so I1, this current is I2. So I1 will be what? Vx upon 3, right? Right? Entire voltage will be what? V. This voltage is only this voltage. This is shorted, which is basically what? I1 times 3 plus 2, that is 5I1, that is 5 times Vx by 3. Okay, this is V. Now this V is again applied across this branch. So current I2 will be what? V minus Vx by 2. V minus Vx by 2. So putting V in terms of Vx, with 5Vx by 3 minus Vx by 2. 5Vx by 3 minus Vx is 2Vx by 3 by 2. 2 cancels. So it will be Vx by 3. So I2 is also equal to Vx by 3, same as I1. Equal to I1. So what will be I? I will be what? Net total current, net current. I1 plus I2. बहुत ही आसानी से very simply I1 and I2 both are same Vx by 3. So Vx by 3 plus Vx by 3, that is 2Vx by 3, right? V we have found out in terms of Vx, I Vx by 3, I we have found out in terms of Vx, 2Vx by 3. Now how we will find RTH, Thevenin's equivalent resistance? Very simply, RTH will be nothing but the ratio of the input voltage and input current. Here in this case V by I. V by I को हम लोग Vx की टर्म सब्स्टिट्यूट करेंगे इसमें, I Vx by 3 यहाँ से, और I मिल गया था 2Vx by 3 यहाँ से. So 3 cancels, Vx cancels. So what remains is 5 by 2. It's nothing but 2.5 ohms. तो हम लोग को RTH across the load resistance RL मिल गया 2.5 ohms. और मैक्सिमम पावर ट्रांसफर होने के लिए RL को वही होना पड़ेगा इक्वल टू RTH. मैं मैक्सिमम पावर ट्रांसफर करती हूँ डीसी नेटवर्क्स. सो करेक्ट आंसर फॉर दिस क्वेश्चन इज 2.5 as RL is RG ohms for maximum power transfer. तो बहुत ही आसानी से मैंने इसको निकाल दिया, इसका सॉल्यूशन. बेसिकली मैक्सिमम पावर ट्रांसफर थ्योरम डीसी नेटवर्क्स में अप्लाई करके, जिसमें इसके लिए इसमें ये बोला जाता है कि RL मैक्सिमम पावर ट्रांसफर होने के लिए इक्वल टू RTH होना पड़ेगा, RTH के बराबर होना पड़ेगा. For maximum power transfer to RL, it should be equal to the Thevenin's equivalent resistance as seen across the terminals of RL. How is Thevenin's equivalent resistance obtained? By first deactivating the independent sources. Here the independent source is 50 volt source, so you have to short it. Then you have to apply some voltage, input voltage say V, which generates some current I. Applying basic circuit analysis, we first found V in terms of Vx, right? Then we found I1 and I2 currents in terms. Then added them, find the total net current I in terms of Vx. उसके हम लोग क्या किया, हम रेशियो ले लिया V और I का. रेशियो लेने से Vx बेस कैंसिल हो गया, क्या बचा, क्या मिला हम लोग को 5 by 2 RTH 2.5 ohms. तो बेसिकली मैक्सिमम ट्रांसफर होने के लिए RL जो लोड रेजिस्टर उसका वैल्यू इक्वल टू RTH 2.5 ohms में देना पड़ेगा. So I have explained all the steps with proper explanation and working. I hope the solution is pretty clear. But if you have any doubts or queries in the solution to a simple question, please feel free to ask in the comments. I will get to answer. And that's all for solution to this question. Also for the subject networks questions, 4 questions came of native numerical answer type in GATE 124 DC paper from the subject networks. Hope if you still have doubt, I hope you watched all the solutions carefully. If you have any doubts or queries, please feel free to ask in the comments, and we'll be glad to answer your doubts. So thanks for watching this video, and that's all. Thank you.